Welcome back to Math 109, Plain Trigonometry. In this video, we're going to take a look at the polar form, or trigonometric form, of a complex number. So in order to illustrate with this, we're going to start with drawing a coordinate plane. Except in this case, we're not going to label the axes x and y. Instead, the x-axis is going to correspond to the real part of the number, and the y-axis will correspond with the imaginary part of the number. Now, I'm not going to ask you to graph a complex number in this class, but we do need this for context with what we're going to talk about with the trigonometric form. So at this point, a complex number is a point on the plane. We could think of it as a vector extending from the origin to that point. If you don't know what a vector is, don't worry about that. That's one of the sections I passed over in the textbook. We can just think of it as a point for our purposes. So this has coordinates x, y. And we'll recall some things that we know from previous study. We'll also call this angle between the real axis and the line extending to our point theta. We'll recall that r, so the radius that's away, is equal to the square root of x squared plus y squared. We also know that the cosine of theta is equal to x over r. The sine of theta is equal to y over r. And the tangent of theta is equal to y over x. Now, what's important for us is that we can rewrite this cosine of theta formula, multiplying both sides by r. We get x is equal to r cosine theta. Likewise, with the sine formula, we get y is equal to r sine theta. So we can now rewrite the number that I have graphed there, x plus iy, as that radius multiplied by cosine of theta plus I multiplied by the sine of theta. Now, this cosine plus I sine is going to be used so frequently when talking about complex numbers that we're going to write this in a more compact form. We're going to write this as r and then CIS, standing for cosine plus I sine theta. So that's how you write a complex number in trigonometric form. In the next video, we're going to look at converting a complex number from the standard algebraic or rectangular form into this trigonometric form.